Hello everyone, in this tutorial we are going to provide a solution to this interesting sequence problem. We are given 5 terms here and we are asked to find the 6th term. If you want to solve this problem, there are two important things to determine. The first one is to determine which type of sequence is this, and the second one is to determine the formula or an expression that can help you to find each and every single term. That is TN formula, very important. Don't forget to like, comment, and subscribe. Let's get started. Let's start with the first one. To determine which sequence is this, we can test, right? Whether it is arithmetic, geometric, quadratic, cubic, quartic, and so on. If it is an arithmetic sequence, we have to have a constant common difference, which means that we have to add the same number to keep on getting subsequent terms. So let's test it. What number can be added to 0 to get 7? Definitely 7, right? But we cannot add 7 to 7 to get 18. Yeah, because 7 plus 7 will give us 14 instead. You see, from here to here is by addition of what? 11. And from this, 18 to 33 is by addition of 15. So this is not a linear sequence. So if it is not a linear sequence, is it geometric? If it is geometric, every term you take, you multiply by a constant common ratio, you will get the subsequent term. So let us test whether it is geometric. If it is geometric, if you take the first term, 0, you multiply by another number, let's say r, it is going to give us 7. So is there any number we can multiply by 0 to get 7? No such number. So from here it fails automatically. So this is not geometric. So if it is not geometric, what else could it be? Is it quadratic? If it is quadratic, the second difference must be constant. So let's see whether that is true. What is the first difference? Let me rewrite the sequence here. We have 0, we have 7, we have 18, we have 33, and we have 52. Remember, this is when n is 1. That is first term, second term, third term, fourth, and the fifth term. We are given only 5 terms. The first difference, you know that from 0 to 7 is by addition of what? 7, right? And from 7 to 18 is by addition of 11. From 18 to 33 is by addition of 15, because 18 plus 15 is 33. And from 33 to 52 is by addition of 19. So you see the differences we have here. They are not the same. They are unique. Then what about the second difference? Second difference. From 7 to 11 can be obtained by adding 4, right? Yeah, if you add 7 and 4 together, you get 11. Add 4 to 11, you must surely get 15. Add 4 to 15, you must get 19. Yay! So since we have a constant common difference here in the second difference, it means that this particular sequence is what? Quadratic. And the general expression that can help us to find every single term is given by u of n equal to an squared plus bn plus c. This is the general form, but we have to determine what a, b, and c are, and that's what we are going to do. To determine that, you can see that from the original sequence, when n is 1, we have 0, right? When n is 2, we have 7. So now let us substitute n equal to 1, 2, 3, 4, and 5. But I think 3 times are enough for us to do this work, because we have already seen that this is quadratic. Let's use just first 3 numbers, 1, 2, 3. When n is equal to 1, what do we have? 1 squared is 1 times a is a, so we have a. B times 1 again, we have b, and we have c. Then what happens if n is equal to 2? We have 2 squared is 4, and 4 times a is 4a, and 2 times b is 2b, plus 2b, then plus c. And lastly, let me take n equal to 3. We have 3 squared is 9, and 9 times a is 9a. 3 times b is 3b, plus 3b, then plus c. Now let us find the first and the second difference. The first difference, what is the difference from here to here? To get 4a from a, you need to add 3 extra a's, right? So we have 3 extra a. To get from b to 2b, you need to add a b. To get from c to c, you don't need to add anything. Or you can take this one and subtract this one, all the same. You can see that 4a minus a is 3a, 2b minus b is b, and c minus c is 0. So this is the first difference here. Then from here to here, 9a minus 4a will give us 5a. Then 3b minus 2b will give us b, and c minus c is 0. This is the first difference. And the second difference, from here to here, 5a minus 3a is 2a. And this is our second difference, 2a. And remember, second difference is constant all through. So what is our second difference here is 4, right? Therefore, this 4 must be equal to 2a. This implies that 2a is equal to 4. If you divide both sides by 2, you have a to be equal to 2. So we have obtained the value of a. What about b? You come back here. This 3a plus b is equivalent to this number here. You see that? And if you take this one, 5a plus b, it is equivalent to 11. So I would like to take this line, only this line. So 3a plus b is equal to, is it 7? Yeah, 7. But we have seen that a is equal to 2. So this is 3 multiplied by 2 plus b equal to 7. B therefore is equal to 7 minus this number, which is 6, minus 6. And b therefore equals 1. What else? We need to find c. When n is 1, you can see we have a plus b plus c. A plus b plus c. And remember, when n is 1, we have 0 from the original sequence. So this is equal to 0. A is 2. B is 1. C is what we are looking for. This is 3. If you take it to the other side, it becomes negative, and c equal to negative 3. Yay! We have obtained a, b, and c. Therefore, use of n is equal to an squared, but a is what? 2 n squared plus bn. B is 1 times n is just n. Then plus c is negative 3, so minus 3. And therefore, this is the nth term of that sequence. If you like, you can confirm it before you find the 6th term. Remember, we are looking for the 6th term. Before we find the 6th term, I would like to test it on which term? Let us test it here. When n is 3. When n is 3, we have use of 3 equal to 2 times 3 to the power of 2 plus 3 minus 3. You can see this is already 0. And 3 squared is 9. And 9 times 2 is 18. Is that term equal to 18? Yeah, definitely. So now let us go ahead and find what we are looking for. We are looking for the 6th term. And the 6th term will be equal to what? A, which is 2, times n, which is 6, squared, plus n again, which is 6, then minus 3. 6 squared is 36, right? And 36 times 2 is 72. This is 72 plus this is 3, right? Oh, I'm supposed to take them all at once. This is 75. Therefore, the sixth term is equal to 75. As simple as that. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.